Alright guys, today we're going to review a little bit more of what I taught you on Friday. It's really not anything different than what we were doing. Again, it's just trying to decide which function do you need. Do you need the original position function, or do you need to find the derivative first and then plug things into that? So let's try it. The first one says a race car's position in feet is given by the function f of t equals 16t plus 20, where t is in seconds. What is the average velocity from 3 to 5 seconds? So this is an average velocity question, meaning we're going to do f of the bigger number 5 minus f of 3 divided by 5 minus 3. Now notice, this is just f of 5 and f of 3. So I am not using the derivative here. I'm using the original function. So first I'm going to plug in 5, then I'm going to plug in 3, and I think we can do 5 minus 3 in our head. That's going to give us 2. 16 times 5 is 80, plus 20 would be 100, minus 16 times 3 plus 20 is going to be 68, divided by 2. So 32 divided by 2 gives me my answer of 16 feet per second. That's the average velocity. Okay, the second question asks for the position of the race car at 7 seconds. Again, position is just a question from the original function. So f of 7, 16 times 7 plus 20, is going to give me 132 feet. Okay. The next question is a little bit tricky. It says, at what instant has the car traveled 84 feet? Now, some of you are going to see that word instant and think that we need the derivative, but that's only if it says instant velocity. This is just a question of time. At what time has the car traveled 84 feet? 84 feet is a distance. So, if that's a distance or a height, then that's saying set the original position function equal to that position of 84 feet. So do your solving here. 16t is 64, divide by 16, so you would get t is 4, which represents 4 seconds. Okay, problem 2 says the position of an object in feet is given by the function f of t equals 10t squared plus 20t plus 5, where t is again in seconds. Here's the big key word. What is the instantaneous velocity at 3 seconds? So this is the problem that I need the derivative for. So first I will take the derivative. Using the power rule, we get 20t plus 20. So now, what is the instantaneous velocity at 3 seconds? I'm going to plug in f prime of 3. So 20 times 3, that's going to give me 60, plus another 20. So my answer is 80 feet per second. B says, at what instant is the object traveling 160 feet? So at what instant is again a question of time, but what they've given me, 160 feet per second, is a velocity. So I want to set my derivative, 20t plus 20, equal to 160. Subtract the 20, so 20t is 140, divide by 20, and I'm going to get that t is 7 seconds. The last question for this one is saying, what is the object's position? Again, position goes back to the position function. What is the object's position at that time from part B? So at 7 seconds, what's the position? I want to find f of 7, not f prime of 7, but f of 7. So plug it in. 7 squared is 49, times by 10 would be 490, plus 20 times 7 plus 5. 490 plus 140 plus 5 gives me my answer of 635 feet. Okay, number 3 says Ryan throws a rock into the air. The position function in feet of the rock is s equals 1/3 t to the third minus 4t squared, where t is in seconds. So basically the only real difference between this problem and what you've seen is instead of saying f of t, I'm calling this position function s. It's essentially the same thing. So the first question says, what does the graph of this position function look like? The part of this graph that we care about is that it almost is a parabola shape down here, and then eventually it will shoot up high again, because it's an x to the third function, so we're talking about a disco graph, opposite sides starting up and down, and since it's a positive leading coefficient, we know it has to finish high, and that means it has to start low. But the part that we're really going to focus on is this part right in here. So the first question says, what is the instantaneous velocity, so not just at what instant, but instantaneous velocity at 5 seconds. So this is a question that I need the derivative for. The reason that we taught you that other notation for finding a derivative is for questions like this. Now I'm not going to be super picky about your notation as long as you're using the right function. Instantaneous velocity again means I need to be using the derivative. So we would say ds dt instead of f prime of t equals 3 times 1/3 is 1, so t squared minus 8t. And then at 5 seconds means I want to plug in 5 for t. So 5 squared minus 8 times 5, 25 minus 40, I get negative 15 feet per second. The next question asks, how high is the rock at 4 seconds? How high is a question of height, position. So this goes back to the original function again, and I'm going to say s is 1/3 times 4 to the third. I'm using the original s function, minus 4 times 4 squared. 4 to the third power is 64, minus 4 times 4 squared is 16. 1/3 times 64 doesn't go in nicely, but 16 times 4 is 64. Use your calculator. I'm going to get negative 128 over 3, or negative 42.66 feet. It's okay to get a negative position. Don't let that scare you. Especially if we look at the graph of this function, we can see that most of this graph was below the x-axis, so having negative positions is not a big surprise. Okay, the last question is a little bit tricky. It's asking at what instant. Now, it doesn't say instant velocity, it says at what instant, so ultimately this is a question of time. But it's asking at what instant is the rock not moving. So the trick on this one is that if it's not moving, that means its velocity is going to be 0. So if we want to know when the velocity is 0, we actually are going to use the derivative, which we found in the other problem was t squared minus 8t, and we're going to set that equal to 0. So then to solve this, you're going to want to factor, take out a GCF, and we get two answers, either time of 0 or a time of 8. So what that means is at 0 seconds and at 8 seconds, the rock is not moving. Which again should make sense based on our graph, seeing that it would stop at certain periods of time. Alright, I will post the answers to both nights of homework on Schoology, the one from last night and tonight. Good luck. You do still have your quiz tomorrow. I'll go over any questions before the quiz and then we'll take it. And then you still have your test on Thursday. Good luck.